Okay, so we're going to be recording this part of the session. If anybody has any objections with the recording, please say so now. Okay, good. So I asked you guys to do a couple of exercises to kind of round out the normalization topic. And basically, I was giving you two exercises that had either a table or some sort of report or invoice or something like that. What you needed to do is to identify the tables, the primary keys, and just validate that the tables complied with the normalization rules. And so remember this, just remember this, because we're still in the design stage of the development of our system. We're still in the design stage. And so remember that in the design stage, the end result that we want, regardless of how we approach the design, the end result that we want are the relational model tables normalized that we're going to implement for the next step, which is the development in whatever software we're going to be using. And so remember that there's two approaches. One is like the first exercises we did, where you are given a problem or a situation or a problem statement. And from that, you have to extract or identify rather the entities. Then you identify the attributes, you identify cardinality, relationships, cardinality. Then from that, you do the ER diagram. And then from that, you get the tables and verify normalization. So that's kind of the process. That's the process you should be following for your project, okay? But there can also be another situation where we already know the end result, meaning that in the previous explanation that I did, once you get the tables and you implement that in the software, you've got your database, you're going to ask for reports. You're going to ask for reports. For example, in the case of your final project, you've got the bakery, Iskra's bakery. And so you're going to want a report that says, okay, so how many brownies were sold last month and to whom? And so you're going to get a table that's going to be a report that's going to give you that. That's what the database should provide. Okay. Let's stay with the bakery example. And also maybe for Iskra's bakery, you're going to be generating invoices. So let's say that Jorge Sosa, I bought 2,500 brownies for a huge party that I'm throwing, and I bought them from Iskra's bakery. And so, and I need an invoice, maybe a factura, okay? And I need that invoice. And so Iska is going to generate through the information in the database, she's going to generate an invoice that says this is for the client Jorge Sosa Lopez, that's client number whatever, and he bought 2,500 brownies that are, the brownies are this code and have this cost, and there's going to be an invoice that's generated. The database is going to be able to generate that. However, let's assume that now it's the other way around. We already have, we've got an example of the final report that we want to generate, or an example of the final invoice. And from that, we want to extract the tables that comprise the database. So that's what we're doing here, okay, in these examples. And we just want to validate that these tables comply with the normalization rules. Mostly in the other case, when we're doing the problem statement, identify the entities, and then go through the process, our tables should be normalized if we follow the rules that we follow when we create the tables that have to do with cardinality. But here we have to extract the tables and we have to verify that. So the first exercise was is giving us a report that has to do with dental appointments for patients. Okay, dental appointments for patients. I don't know how many of you have had to go to the doctor recently. I hope none of you have. I hope none of you have. But in my case, I've had to go to the doctor a lot these past few weeks. I've had to go to the normal doctor to get a checkup. I've had to go to the dentist back in, I think it was February or March. I don't remember anymore. One of my teeth broke. One of my molars broke, and I've been going to the dentist to get that repaired. I went to the normal doctor because, again, I hope none of you or your family members or loved ones have had COVID. But one thing is that you have COVID and you survive COVID, but the long haul, what's called the long haul COVID uh, symptoms persist. So there's a lot of things of the post-COVID that a lot of us are dealing with that have had COVID that are really, really not cool. So I went to the doctor for that. And I also have this lingering problem in my arm that is still not being fixed. So I had to go to the orthopedist. Now, why am I mentioning all this? Because I don't know how many of you have had to make doctor's appointments. So usually you just call the assistant. You say, I want a doctor's appointment. The assistant says, okay, I can set you up for May 15th at 11 a.m. and you just write that down. And usually the assistants of the doctor just have this sort of like notebook where they write things down, and that's that. And that's basically the information system, is that notebook that the assistant has. But it was curious because a couple of oh, and I also had to do the MRI. And you also make an appointment for the MRI. And I found it very interesting that at least with Almater and some of the doctors in Almater, so I asked for the appointment and the assistant wrote down the appointment, but suddenly I got a WhatsApp message from a virtual assistant that was saying, okay, Jorge Sosa Lopez, you have an appointment for the MRI on Thursday at 2 p.m. Please confirm yes or no that you're going to come to the appointment. And it's curious because you know that I like to talk a lot and write a lot. So I remember I answered, yes, I confirm that I'm going to be going to the appointment for the MRI, blah, blah, blah. I wrote about 2 or 3 lines there. I click send, and the virtual assistant kind of gave me a slap and said, I'm just asking you to say yes or no. I felt really offended that a virtual assistant said that to me. And so I just answered yes. And the orthopedist also, actually, I had a confirmation from a virtual assistant from the appointment. So that's interesting here for these dental appointments. This could be a part of an information system. And right now, there's a lot of virtual assistants and communication with that's done via electronically. So you can get an email to confirm the appointment. You can get a WhatsApp message. You can get automated things that are coming from the database. So this dental appointments list that we're getting a report right now, this database could be a database that's being used or an information system that's being used to manage the appointments for a group of dentists that are part of a consortium. Okay. And so that's kind of the information we have here. And so what do we have here? We identify, we've got a staff number that's kind of the employee ID or the dentist ID. It's associated to a dentist's name. Right now on the list, we've got 3 dentists, Tony Smith, Helen Pearson, and Robin Plevin. We've got patients, and each patient is identified by a patient number. So we've got Gillian White, Jill Bell, Ian McKay, and John Walker. And each of these has a unique identifier. Then there's an appointment date and an appointment time. Okay. And there is a field here that says surgery number, or meaning it might be related to the type of procedure that's being done to the person relating to the appointment. Maybe not necessarily a surgery in itself, but a type of procedure. Okay. So what are the entities that are related to this to this table that we're giving here? Somebody give me an example of an entity that's clearly one here.
Staff number.
No, an entity. Staff number is an attribute or a field. The entity is the remember that entities are these things that are related to the problem. So what would be an
With a
entity?
patient
Patient, correct? The patient.
or
What else?
dentist.
The dentist would be another entity. The appointments would probably be another entity. And remember that the entities are going to generate tables in the end. Okay. So basically, what we need to do here is kind of separate this table into different tables that are going to comprise the information. Just validate that these follow the normalization rules. So, as they say, work smart. That doesn't necessarily mean work hard. I took the liberty of reviewing your exercises, and so I kind of had help from House Spice Girls Remastered. Thank you guys. You did a very good structure of your work. So I kind of took your solution there. Um, and so basically we're going to separate this into a few tables. So there's going to be a dentist's table. It's going to have the dentist name and the staff number. Remember something. Remember something. Right now we're just doing the separation. But when we do the separation, if we want to add new fields to the structure, we could. So right now we've just got staff number and dentist name, but we could also add I don't know, we could add here another field that might be, what would be interesting to know about the dentist, maybe the specialization, okay? Maybe the specialization of the dentist, we could add that if we want, okay? We can add as many additional fields as we want, as long as we're complying with as long as these fields don't affect the normalization rules. So the dentist's table is going to be one of the tables we identify. And what is important for normalization, we need to identify a primary key. And so the staff number is kind of a no-brainer here, that that's going to be our primary key because it uniquely identifies each of the dentists. Then we're going to have a patient's table. Here in the patient's table, we've got the patient name and the patient number. The patient number is going to be somehow the ID. We could add other fields here if we wanted. We could add maybe a field here that would be, I don't know, maybe the address. Okay, for each of these. We might want to add another field if we want. That could be, I don't know, maybe the phone or the cell phone number if we wanted. Okay. We can add those. We can add as many fields as we want, just to complement the information. As long as we're not violating any of the normalization rules, that's fine. We can add this. Yes, go ahead, please. I think
And if
Andrea.
we add them, we have to invent like the information that we are going to add, or how do we do it?
No, this is what I'm saying here, and this is just an example that in the case of this example, we're already provided information. I'm just saying that when we implement this, this isn't necessarily the only information that's going to be there. When we implement this, we can add other fields that make sense if we want. If I were to tell you, besides identifying the tables, add any fields that you consider are important for each. And you added these two. For this example, well, you don't know the information of the addresses or the cells. Right now it would be blank. It would have to be filled afterwards, okay? This is just identifying what we could add. Okay, right now we would need to ask Gillian White for her address and cell phone. No, we don't have that information right now. Okay, is that clear, Andrea?
Yes, thank you.
Okay, but we could add these if we wanted to, if they made sense to the problem. Now, there's something here that's a bit debatable, okay? It's a bit debatable. Remember that part of the normalization rules are that the fields have to have atomic values. Remember that? Remember, these are going to be questions in the exam. So can somebody remember what we meant by atomic values?
Indivisible values that they're the simplest form.
Correct. Correct. They're indivisible. So it's debatable here if dentist name, if the names should be separated into uh, two fields, one for the first name and one for the last name. Okay. If we were to wanted to be very strict, very strict, we might say, you know what, the dentist name and the patient name, those aren't atomic values because you've got two things there. Tony Smith and Helen Pearson, Gillian White, you've got the first name and the last name. You need to separate those into two. Okay, that's debatable. Okay, if we leave it like that, it could also be correct. But if you would want to be very strict, you might say, well, I'm going to have dentist first name and dentist last name, patient first name and patient last name. Okay, that could be something that we could do. Okay, if somebody would say, you know what, this isn't an atomic value. Okay, right now for this example, we can leave it like that. And lastly, we have to have some table that has to do with the appointments themselves. Okay. Now, here it's important because this is the example where we need to validate the normalization. And so remember that in the end, we need to be able to clearly and uniquely identify a record from the table that doesn't generate confusion with other records that might have similar information. That's why the definitions of the primary keys are important. And so we've got an appointments table. And so what is the information that's important with regards to an appointment? Okay, so first off, the patient, the appointment date and the time, and also who is the dentist that's attending the person. And also to be able to identify maybe the type of procedure that's being done to the patient. Let's assume that you're not going to have the same patient go to an appointment at the same hour. Okay, let's assume that a dentist isn't going to schedule the appointment at the same hour. So we're going to have that. And so we get all this information in this table, and it might make sense to say, okay, our primary key is going to be a combined key. Remember that these are called composite keys that combine these attributes, okay, into one primary key that has to do with all of them. And let's see, Alejandro, you raised your hand. Please go ahead.
Yes, Professor, I have a question. My team and I use the appointment, the date and the time together because we thought it had to be like in one, not separated like you have here. So would that be wrong, or would it still be okay?
Okay, let me see if I understand correctly. If I remember, these two were one is one attribute. You mean?
Yes.
Yeah, that's fine. Yeah, because actually here it seems like it's just one attribute, right?
Yes.
So you can have it as one, or you could have it separated. Either way is correct. Because
Okay.
actually there is a type of remember that in the end, Alejandro and the rest of the group, remember that in the end we're going to implement this in a software, and we have to define data types. Okay, so for example, this data type here, this is alphanumeric. It's similar to programming where you define data types. This is alphanumeric also. This one also. But this one could be either a date data type or a date time data type. So you could actually have a data type where you have the date and also a timestamp on it.
Okay.
So if you did it combined,
Yeah,
it
makes sense.
wouldn't be incorrect. Yeah, it wouldn't be incorrect.
Okay, thank you.
Okay. Oh, sorry. There we go. Okay. And so this would be the solution that we could have. Now these tables are normalized because we've got our primary key. The attributes depend on the primary key, and they only depend on the primary key. Okay, and remember that those are the rules that should be followed or need to be verified with regards to normalization. Okay, Okay, questions with this one? This is in the PowerPoint. It's also going to be recorded so you can have it as a reference. Okay. Questions before we go to the jump over to the next one. Okay.
No.
Okay. Good. I'm going to clear this. Let's jump over to the next one. So in the next one, what we have is that we have a sort of like an invoice for a purchase. In this case, it's for an art gallery. Mm. And so we've got the information regarding the purchase of a series of artworks, okay, that are related to the artworks that are related to some artists, and each of them has a sale, a price. And this is an invoice of somebody who bought something. This could be, again, similar to the Iskra bakery. So in the end, your database for the bakery would want to generate an invoice like this, the customer and what the customer bought. Okay. So we want to extract the tables from this. So can somebody tell me examples of entities relating to this problem that we might have to identify?
The customer?
The customer, correct. Correct,
The
yes.
artist.
The artist. Hmm?
The,
The transactions,
The
like
transaction, the
yeah.
purchase, transactions, the artwork.
Yeah, that's it.
specific
That's the artwork. Yeah.
Yeah. So these are examples of the kind of the entities, and remember the entities are going to somehow be reflected on the table. So coming up back over here, and I also took the liberty of doing some copy paste from House Girls, Spice Girls Remastered. Remember that whenever you do a reference something, put the reference there. So that's why I'm putting it there. And so we identify a customer table where we've got our customer information and customer ID. Again, it's debatable if we want to be very specific and maybe separate the customer name and first name and last name. And if we want to separate the address into many parts, we could do that if we want. Um, um, Sometimes addresses are separated into the different fields of an address. So the number, the street name, the city, etc. Or sometimes the address is just
Professor, sorry for interrupting, but the L3J isn't the zip code.
the L3. It's, yeah, that's kind of a format. Yeah, it seems to be a format of the zip code. Yeah. Mhm.
Okay. It's because we added, like, we
Oh.
invented a customer ID, and that
Yeah.
will be the zip code.
Yeah, that's a good observation here. So here, oh, that I hadn't noticed this. That's actually true. This here, you guys, you put a customer ID here, but this is actually the zip code here. Okay. So the field is correct. The field is correct, but you would need to create a number here for the customer ID because it isn't identified here in the it isn't identified here in the invoice. Yeah, that's a good observation, Estrella. So this would be, I don't know, 100. You would identify a specific customer ID. Okay. The format for this zip code is kind of weird because it's LSL3J454. This seems to be, I would venture to say that this is not in the United States, that this is maybe in Canada. It's kind of it has kind of a weird format for the customer ID. So yeah, the customer ID would be a number that in this case isn't identified. We would have to fill that in or create it. Okay. So yeah, here it would be the number that we would add. That's a good observation. Thank you, Estrella. So that's information that we don't have. We identify a customer ID. We would need to create a customer ID for this. And so we've got a customer table. We've got an artist table, and here we identify that each artist has an identifier. And so each artist is going to have a name and an artist number. Okay. Then we've got an art piece table. Okay. And the here in the art piece table, I've added an art piece ID column there that we can use to identify the art piece. This is a new column that we've added. And we've got a purchase table that's going to have what's the information that we need to identify a purchase, who did the purchase, which is a customer ID, what pieces were purchased, when they were purchased, and what the artist was related to. And so this is going to give us that information. Okay, this is going to give us that information, and this would be the combined or composite. This would be the combined or composite primary key here that we've got. Okay, so this is one way of doing the separation. Okay, questions with this one? So basically, what we could add for example, for the purchase table, we could add if we wanted to, instead of having the composite key, we could add a purchase ID attribute here. We could add that if we want, and in that case, we could identify each purchase with a specific ID if we wanted it, and that way we wouldn't need to generate a composite key. That could be another that could be sort of another alternative. Okay. Questions with this one before we move on?